about synchronization and the necessary conditions for the synchronization, like, and we'll see the methods of synchronization. First of all, in the last class, we have learned that the lack of synchronization causes lack lack of sync causes data inconsistency and data loss, or sometimes the deadlock. Now we are going to see the necessary conditions which can cause these problems. Necessary conditions for sync problems. Like, the first one is there should be a critical section in the programs which are communicating with each other. There should be a critical section, and like the both processes are executing in preemptive mode. If these two conditions are satisfied, then the set of processes which are in these which satisfies these conditions can cause sync problems. It means that can cause the data inconsistency or data loss. Let me give an example and explain with it. Let's take an example programs in which a program one is executing the line variable v is equal to v plus 1, and whereas another program 2, is executing the statement that v is equal to v minus 1. Now in both the executions, first the given instruction is divided into further instructions, like it will divide into parts. Instruction 1 will be loading the value of variable b into any register r. Loadings value v in r. Instruction 2 will be incrementing the value of the register. Then the third instruction will be storing the value of r in C. Similarly, the program 2 will also be divided into these steps. Now, as the CPU is in preemptive mode, it can preempt at any statement, like executing at after at any statement it can remove. So let's assume that the program 1 has preempted after executing I1 and I2. Let's assume that P1 is preempted after I1 executing I1 and I2. Then the value of the current value of V is still V, mean not change. and the register which has stored the value of v will be storing v plus 1. Now, the moment it prints from the CPU, the program 2 will start executing, which will change the value of v to v minus 1. Let's say this time the program is completely executed the program 2, CPU completely executed the program 2, then the final value of the v will be v minus 1. Now, as the program 2 is completed execution, then after execution the value of v will be minus 1. Now, the moment the program 1 again starts executing, it will replace the value of the v to r, which is currently now v plus 1. So the final value of the v will become v plus 1, but as we just execute program 1 and program 2 independently, the final value should remain v. But in this case, due to the sync problem, we are getting the issue that the value is incrementing by one extra. This is called data loss. So to prevent this, we're going to use some techniques which are called synchronization techniques. This problem can be eliminated by executing the critical sections in synchronization. What do you mean by synchronization? Synchronization is the process of executing one after another. So to avoid these problems, you have to execute the critical section of each process one after another independently, which will give the correct result. So this can be represented as a program with an entry section. This is known as the entry section, and this is known as the exit section. And when a program enters into the entry section, it should not leave it, the other process should not be executed by the CPU until it completes its entire critical section. Now, once the critical section is completed, it will go from the exit section and allow the other process to perform its critical section, execute its critical section by the CPU. In this manner, we're going to execute the both processes independently. So to achieve independency in executing the critical section, we use synchronization algorithms. So this is all about the synchronization, conditions of the synchronization, importance of the synchronization, and the goal of the synchronization. I hope you understand. You have got a clear idea on synchronization, and the next OS class will start the synchronization algorithms one by one. And I hope you enjoyed this video. Thank you for watching.